Hello, pre-calculus students. Today I'm going to teach you how to complete the square on one side of the equation. Now, you can go to YouTube and lots of other video places on the internet and find about completing the square on both sides of the equation. But the approved method on this, and you can see this in the textbook on page 140, is to complete the square on one side. And you do need to become sophisticated enough with algebra to be able to handle more than one approach. This is the method I'm going to expect you to show in a quiz, and it will eventually show up also on the test. So we need to learn how to complete the square on one side of the equation. Now, the textbook does something very strange. It calls the vertex form standard form. That's not standard form to me. Standard form to me is, let me go ahead and type that real quick. Standard form is in this form where you have the f of x is equal to ax squared plus bx plus c, and then that letter a, that coefficient a, and that coefficient b, and the coefficient c show up in the quadratic formula, which is convenient. And that a is the same a as this a in the vertex form. At any rate, the book calls vertex form standard form, but know that when I say standard form, I mean this. This is what most of the world means when they say standard form. Okay, so as you can see, this first example, my first example here, is a fairly simple one, and it's in standard form. Now we're taking advantage, when we're completing the square, of this being a perfect square or close to it. It's not really close to it yet. If this had said 25, it would be a perfect square, because if you take half of this linear coefficient and square it, you get 25, and if you add that, if that were here instead, then you'd have a perfect square. So it's pretty close to a perfect square, but it's not quite there. So we're going to make it a perfect square. By completing the square. So you'll notice I pushed that 23 a little further to the right. Nothing's changed. If I simplified this now, I would get the same thing above here, which is why we solved down in pre-calculus, because that means the equation above it is equivalent to the equation below it. Now I'm going to change that, but before I change that, I want to keep in mind what my target is. My target is to get a completed square, so I'm going to pull this up so I have something to complete here. And it's going to have something inside this with the x, just like we've got the minus h up here. In fact, the thing that I'm looking for is half of this coefficient. Half of negative 10 is negative 5. So I'm going to want to insert a negative 5 right in there. And now it's not equal to the equation above. Here's why. X minus 5 squared is going to be x squared minus 10x plus 25. So to make this part match what is equal to here, I need to put in 25 right there. But by putting a 25 in there, it's now no longer equal to the equation above it. So I need to make that equal, and the way I make that equal is by balancing out the fact that I added a 25 here. I'm going to take away a 25 on the outside. And so now those things actually balance each other. And if you'll look above, if I were to simplify this expression by removing the parentheses, the two 25s would cancel each other out, and I'd end up with what's above. Okay, so now these two lines, these first two lines, actually are equivalent to each other. The only thing that's not is this one. Now remember that this part of it is the same as the x squared minus 10x plus 25. So all I really need to worry about is what is 23 minus 25? Well, it's negative 2. And now, I'm going to get it inside the equation, this is equal to the step above it, which means all three steps are now equal to each other. Only now this is in vertex form, and telling me what the vertex is actually quite simple. The vertex is 5, negative 2. And you can see how I could work this whole thing backwards and get back to the standard form. You know, square the x minus 5 squared. Go ahead and write it out. Then combine like terms and end up back where I started from. So now this is also very convenient to find the x-intercepts. To find the x-intercepts, I only need to set the y, or in this case the f of x, equal to 0. So that's what you do first. Then the next step, I want to get x by itself eventually. So in this case I'm going to add 2 to both sides, which is going to give me something that looks like this. I don't like the fact that this is on the wrong side, so I'm going to rewrite it so that x minus 5 squared is on the left and the 2 is on the right, which looks like that. And now there's only 2 things left to do here to get x by itself. I have to undo that square, which means we have to take the square root of both sides. And then I have to undo that minus by adding 5 to both sides. So when I take the square root of both sides, keep in mind that I'm going to get a plus or minus. So now I'm going to get two solutions. By taking the square root of the right side, I get plus or minus root 2. And now I'm going to add the 5 and finally get down to what my solutions are. My solutions are going to be 5 plus or minus root 2, which that actually stands for 2 answers. It stands for 5 plus the square root of 2 and 5 minus the square root of 2. And as you can see, it's very convenient to find the x-intercepts once you have it in vertex form. Okay, now I've moved that example over here to the right side of the screen, so if you want to refer to it, it's there. It also conveniently tells us the standard form in the vertex form. So now here's example 2. The first thing that I notice is I've got an a coefficient that's not 1. So that's kind of a pain to do in terms of completing the square. And our current Algebra 1 and Algebra 2 textbook do a very strange thing about completing the square. And I would much rather do something that involves turning this coefficient into a 1. The easiest way to do that is to divide. We're going to divide, but we're not going to divide the whole expression by 2. First of all, you see that you've got an odd number here. That's going to make it a little harder. The second thing is it's not absolutely necessary, because if you look inside there, you can see that these 2 terms, if I did divide them by 2 or factor out a 2, I do have the beginnings of a perfect trinomial square. So the first thing I'm going to do is I'm going to factor the 2 out of the first 2 terms. And I'm going to push that 7 out of the inside of the parentheses so that it's not as big an issue right now. So it's going to look a little like this. When I factor out that 2, I get x squared plus 4x plus something. I don't know what that third term is yet. And right now, if I were to just distribute that 2 and then recombine the 7, I would get all of these same terms. So these 2 are currently equivalent. But let's keep in mind the target. The target is to get some perfect square right there, which means I need to know what that perfect square will be. So inside there, I'm going to take that 4, that positive 4, and cut it in half, and that'll tell me what goes in here. And it's going to be a plus 2. So that plus 2, if I did square it, would not give me a 0 here. It would give me a 4, because 2 squared is 4. So I'm going to put in 4 here. But now it makes it imbalanced compared to this equation. So that 4 I just added in there has to be balanced somehow. Well, how do we balance? Well, how did we balance it last time? Well, we took away something to make up for the fact that we added. But that's not really a 4 because there's this 2 here. So it's really 2 times 4, which means I need to take away 2 times 4. So I'm really taking away 8. And now if I look and see, if I were to expand that equation, this would give me 2x squared plus 8x plus 8 plus 7 minus 8. And once again, those 2 extra 8s would cancel out, and I'd end up being equivalent to the expression above it. But this one's now not equal. Now this part of it is equal to this part of the other equation. So the thing I need to concern myself with is this stuff on the outside, which is going to be 7 minus 8. And 7 minus 8 is negative 1. So the equation I was looking for in vertex form is 2 times the quantity x plus 2 squared minus 1. which that tells me what the vertex is. The vertex is at -2, -1. And it tells me that this curve opens downward. So that's how we complete the square. Next thing is I want to take advantage of the fact that I know this to be able to find the x-intercept. So once again, I'm going to replace f of x with 0. And that looks like that. Again, I don't like the fact that that x part is on the wrong side, so I'm going to first add the 1, and then I'm going to swap sides with it. Okay, actually I'm dividing by 2 first, and now swap sides, and it looks like that. So it's actually pretty simple to see that. And now I've only got 2 more jobs to do, and you should notice this becomes very much the same process every time once we get to this point. You got the square, perfect square, isolated on the left, and on the right side you've got a constant. And then all I have to do is take the square of both sides and undo whatever this is, which in this case is going to be subtracting 2. So first thing I did is take the square root of both sides, which is going to get me x plus 2 is equal to, remember that we get 2 answers when we take the square root. We get plus or minus square root of 1/2. Now, square root of 1/2 actually simplifies to the square root of 1 over the square root of 2, which is going to be 1 over the square root of 2, which, if you remember rationalizing the denominator, ends up getting you the square root of 2 over 2. So I'm going to subtract 2 from both sides, and I should end up with -2 plus or minus the square root of 1/2. Again, the square root of 1/2 is actually going to be square root of 2 over 2, so I end up with 2 answers. -2 plus square root of 2 over 2, and -2 minus the square root of 2 over 2. And that's the end of the second example. Okay, now for my third example, I'm going to take the example that's on page 140 in the book and show you how I would animate that so that it makes it a little clearer for you. So the first thing I need to do is think about the fact that there's that negative coefficient in front. I don't like that negative coefficient there, so we're going to factor out a negative coefficient from the first 2 terms. And that looks like this. So after I factor out a negative coefficient from both of these, I get a negative in here for 6x. And if you think about distributing that negative, that's going to make the x squared term negative and make the linear term positive. So what's on this first line is the same as what's on the second line if I simplify it. And again, I want to think about what that's going to look like in my target. And it's going to look a lot like what we currently have, with one big exception. We know that there's going to be a perfect square term inside here. And it's not going to have this anymore. And it's not going to say -8 because there's going to be some other coefficient there. So the next thing I want to do is think about what half of -6 is. And half of -6 is going to be -3. So -3 is what I want inside the parentheses here. And again, that's not equivalent to the expression above it, but it's close, because this part of it now is the same thing as this, except I've got to complete the square. So I want to think about what -3 squared is going to get me. Well, that's going to get me 9. So I have to add 9 in here. The problem is that's not really 9. That's really a -9. I'll tell you why. See that negative out there? So in terms of this expression, I really had to subtract 9 to put that 9 in there. Which means at the end, I have to add 9 because I'm really subtracting a -9. Okay, so once again, I added a 9 in there to complete the square. I'll always be adding something in here for this middle term, because even if this coefficient is negative, a negative squared is going to get me a positive. So -3 squared is a positive 9. But to keep it balanced, I have to keep in mind that I've really just subtracted that, so I have to add 9 to the outside. Now again, if I distribute this negative and then add all these terms together, I'm back to what this is. that first line. So this is very close to what we're looking for. We're almost in vertex form. The one thing that's wrong is that right now the first line and the second line are equivalent, but the third line is not. So to make it equivalent, I have to resolve this negative 8 plus 9, and that is a positive 1. And now it's in vertex form, which means it's very easy to read what the vertex is. The vertex is going to be 3, 1. And from that information, I can now find the x-intercept. So remember that we take this equation, and instead of f of x, we say it's 0 is equal to that. Well, since I'm going to want this part on the left anyway, I might as well just say the opposite of the quantity x minus 3 squared plus 1 equals 0. Equals 0. So now I'm going to subtract that 1 over. Okay, so now I'm going to have to deal with the fact that there's a negative out there and multiply both sides by negative 1. If I do that, I'm going to end up with x minus 3 squared equals 1. Hey, now this one's convenient. Take the square root of both sides now. That's going to be really easy. We're not even going to have a radical left. We're going to end up with, because the square root of 1 is plus or minus 1. So that means that I'll add 3 to both sides and end up with, final answers are going to be 3 plus 1, which is 4, or 3 minus 1, which is 2. Those are my two x-intercepts. And we're done.